4114. What feature is associated with a temperature inversion? A. A stable layer of air. B. An unstable layer of air. C. Air mass thunderstorms. The correct answer is A. A temperature inversion refers to a situation where the normal temperature profile in the atmosphere is inverted or reversed, meaning that temperature increases with height instead of the usual decrease. In this case, a stable layer of air is formed, where cooler air is trapped near the surface and warmer air exists above it. Inversions can occur in various atmospheric conditions, such as radiation inversions on clear, calm nights or subsidence inversions associated with sinking air in high-pressure systems. The stable layer of air in a temperature inversion prevents vertical mixing and restricts the movement of air pollutants, moisture, and sound waves. This can lead to the formation of fog, smog, or trapped pollutants, affecting air quality. 4125. A temperature inversion will normally form only A. In stable air. B. In unstable air. C. When a stratiform layer merges with a cumuliform mass. The correct answer is A. A temperature inversion will normally form only in stable air. Temperature inversions occur when the normal temperature profile in the atmosphere is reversed, resulting in a layer of air where temperature increases with height instead of decreasing. This typically happens in stable atmospheric conditions. In stable air, cooler air tends to sink while warmer air rises, leading to a stable layer near the surface. The stable layer prevents vertical mixing and acts as a lid, trapping pollutants, moisture, and other atmospheric components below it. This results in reduced vertical air movement and limited dispersion of pollutants. 4200. Which weather conditions should be expected beneath a low-level temperature inversion layer when the relative humidity is high? A. Smooth air and poor visibility due to fog, haze, of low clouds. B. Light wind shear and poor visibility due to haze and light rain. C. Turbulent air and poor visibility due to fog, low stratus-type clouds, and showery precipitation. The correct answer is A. A ground-based inversion favors poor visibility by trapping fog, smoke, and other restrictions to visibility in the lower atmosphere. Wind just above the inversion may be relatively strong, creating a wind shear zone between the calm air below and the stronger winds above. 4105. What causes surface winds to flow across the isobars at an angle rather than parallel to the isobars? A. Coriolis force. B. Surface friction. C. The greater density of the air at the surface. The correct answer is B. Friction between the wind and the surface slows the wind. As frictional force slows the wind's speed, Coriolis force decreases. However, friction does not affect pressure gradient force. Pressure gradient and Coriolis forces are no longer in balance. The stronger pressure gradient force turns the wind at an angle across the isobars toward lower pressure until the three forces balance. The angle of surface wind to isobars is about 10 degrees over water, increasing with roughness of terrain. 4106. Winds at 5,000 feet AGL on a particular flight are southwesterly, while most of the surface winds are southerly. This difference in direction is primarily due to A. A stronger pressure gradient at higher altitudes. B. Friction between the wind and the surface. C. Stronger Coriolis force at the surface. The correct answer is B. The difference in wind direction between the surface and 5,000 feet AGL, above ground level, is primarily due to friction between the wind and the surface. Near the surface, the wind experiences more frictional effects from the terrain, vegetation, and surface features. This frictional drag slows down the wind and causes it to be influenced more by local topography and surface conditions. As a result, the surface winds are often deflected and influenced by local factors such as mountains, buildings, and vegetation, leading to deviations from the prevailing wind direction. In contrast, at higher altitudes, such as 5,000 feet AGL, there is less surface friction acting on the wind. As a result, the wind is freer to flow in a more geostrophic manner, following the pressure gradient force and the Coriolis effect more closely. The wind direction at higher altitudes is primarily determined by the pressure gradient force and the Coriolis force, resulting in a different wind direction compared to the surface winds influenced by friction.